All right. We're going to go ahead and get started. So welcome to our webinar introducing the risk management module. We have an action-packed webinar with a presentation and demo. We are nearing completion of phase 2 of the risk module, and we thought it would be a good time to update you guys on what the risk module looks like today and in the near future. So I'm going to go ahead and start with introductions. Hi, my name is Sherry Baucom. I am the product marketing manager for Irth Solutions. I have a pipeline integrity engineering background. I've been in pipeline integrity since 2010 when I started with Williams as an integrity engineer 1. And Anup, I'll let you introduce yourself.
Thank you, Sherry. My name is Anup Raniga. My experience is primarily in the risk management field in varying varieties. I have extensive experience in the oil and gas industry, including conducting pipeline risk assessments for owner-operator companies. And currently, I am the product manager here at Irth.
Great. So I'm going to start off today's webinar by discussing Irth and why we decided to develop a risk module. And then Anup is going to explain how the probability of failure is calculated and what models and data are used to drive that. We're going to keep it high level so we have time to actually demo the risk module, but he'll go into some detail with that. He'll also describe the workflow associated with running a risk analysis in SIM, and then obviously he will demo the risk module from start to finish. And then we'll end the webinar discussing future enhancements that are on our roadmap. So SIM is part of the Asset Integrity Software as a Service product line. Irth offers 2 other categories of SaaS solutions, one focused on damage prevention, which a large part of that is 811 ticket management. And then we also offer land management software, which helps electric companies, renewable companies, and also pipeline operators manage right-of-way agreements and landowner information, for example. So those 2 product lines help you guys when you're having to dig up your pipeline for mitigating anomalies, for example. All 3 product lines provide intelligence to help you guys manage your assets. So just like several products make up Irth Solutions, SIM or Asset Integrity for Pipelines also encompasses several products or modules that we call it. So the inline inspection, management, and analysis is what we commonly refer to as our core SIM product line. We also have a dedicated module for all things internal corrosion. We have a newer module for managing and analyzing external corrosion surveys with the external corrosion module. And then we also have a pressure cycle fatigue analysis specifically for analyzing cracks and figuring out the life of cracks based on your pressure data and cyclic fatigue severity. And that lives in the anomaly analysis or integrity compliance process. And then we also have a geohazards module that's in development. So one commonality that all of these products share, including damage and land, is that they all manage data that can be utilized to calculate risk. And that's really one of the drivers, one of the main drivers for us developing a risk module. So for you guys that are familiar with SIM, SIM houses a wide range of integrity data, and our clients are continually asking us, how can we best utilize the data that's in SIM and turn it into actionable information that helps you guys improve your integrity management program. So how can we help you guys make more informed decisions based on the data that's in SIM? And that's really the impetus for us developing a risk module. So I wanted to show you this graph that really shows us the direction, or shows you guys the direction we want to go with our risk module. This comes from a client of ours who has one of the most sophisticated integrity programs I think I've ever seen, because they really found a way to integrate integrity data with risk and bring those 2 departments together who typically operate sometimes separately, and use integrity data to inform risk, but also use risk to inform their integrity decision making. So this graph is actually showing how one might calculate the probability of failure along the pipeline, one particular pipeline, and determine where the POF exceeds the company's risk threshold. So the risk threshold is that dotted purple line, and the locations that exceed the threshold might be identified for mitigation to drive down the risk. So, and one of the main drivers of this POF calculation is inline inspection data. So how many of you are using inline inspection data / corrosion growth rates to calculate your risk, right? So this is the direction we decided we wanted to go with our risk, risk module, making sure that we use integrity data that's already in SIM, especially inline inspection data, to calculate the probability of failure, along with a lot of other data inputs that Anup will talk about. The models that were used to calculate this probability of failure were derived by CFIR Technologies, who is our partner in this endeavor. They're considered experts in the industry, and I'm going to hand it over to Anup to explain CFIR's role and also provide information on the risk models that they've created.
Thank you, Sherry. So our risk module is built in conjunction with the models that are provided by CFIR Technology. Irth leverages CFIR's research and development as the foundation of our risk models. These models have been refined and improved through 25 years of use by oil and gas operators around the world. CFIR provides industry-leading expertise. In fact, their SMEs contributed to the development of CSA Z662 risk and reliability standards. CFIR utilized industry data from 1968 to 2019, so over 5 decades worth of data, including data from the FINS incident database, to test and validate their risk models, so that they're able to ensure that they were in line with operator experience. And so, by partnering with CFIR and utilizing their expertise and experience in risk and reliability, we're able to take advantage of their industry-leading quantitative risk analysis. So there are 2 available methodologies for calculating risk within our risk module. The first one is probabilistic or structural reliability-based models. These are based on foundational engineering principles of structural reliability. So these are typically applied to the time-dependent threats such as corrosion and cracking, and it's based on the relationship between the load that's applied to the pipe and the pipe's resistance to that load. So we're looking at pipe geometry, strength and strength characteristics, so your smice and tensile strengths, for instance, and the pipe's ability to resist the load. So any accidental loading, sudden strikes, for instance, and gradual deterioration, so corrosion. Both load and resistance are modeled using probability distributions to account for the uncertainty in both. So we don't know exactly the exact SMYS value or the tensile strength, and nor do we know the exact resistance that's been applied. Hence, we need to build in uncertainty, and having that uncertainty built into the models allows us to be able to create more expansive risk assessment results. And failure occurs when load exceeds resistance. So when the pressure, for example, when pressure cycling results in cracks, or when the operating pressure exceeds the capacity of the corrosion affected pipe to contain product, which would result in a leak. Historical based models, on the other hand, utilize historical data and statistical methodologies to come up with a probability of failure. So these are typically applied to time-independent threats and discrete events that cannot be explained using mathematical principles. So for example, weather and outside forces or incorrect operations. So these historical based models consider historical incident data and apply statistical techniques to develop the failure rates. Once these failure rates are applied or developed, adjustment factors are applied to produce a probability of failure. We've delineated the threat types into 2 separate buckets for modeling. So first off, the structural reliability-based models, because they are based on foundational engineering principles, corrosion, cracking, and third-party damage are modeled in our first phase of SIMRISK using structural reliability models. The discrete events are modeled using a historical based model. So this would include incorrect operations, manufacturing defects, weather outside forces, and amongst others. So in terms of how the POF calculation works within SIMRISK, SIMRISK would take the 9 ASME B31.8S threats that are described within the CIFER models and feeds data through either their structural reliability model or historical-based models, depending upon the threat. Risk data that's fed in comes from ILI, GIS databases, and other sources, and they're fed into the 9 threat models to inform the calculation of POF for each threat. These calculations are categorized also by failure modes, giving us a total of 27 probability of failure scores. So once we have the 27 probability of failure estimates, we've delineated by the type of release, whether it's a rupture, large leak, or a small leak, giving a little bit more insight into what type of release we would look at and the associated probability of failures with that. The POF is then calculated on a rolling mile basis, which would provide additional context needed to utilize the POF values and build actionable integrity management plans. So we're looking to locate along where the pipe route action is going to be required in order to address that risk. The rolling mile risk calculations are based on assessing risk on each dynamic section and then calculating across a linear representation of the pipeline. In this calculation aids in developing actionable risk management programs. All right, so the workflow that we've identified is as follows. We've identified, first off, centralized data management, so leveraging the data that's already within a SIM and has gone through the ingestion and alignment algorithm to reduce errors and minimize time on data gathering and treatment. So by utilizing the data that's already within SIM, we're expediting the data loading greatly. And we're able to fill in the defaults where data is limited or unavailable so that we're able to calculate risk without having to omit key data points. Once we've incorporated the data from SIM and accounted for any defaults wherever data is not available, we're able to feed that data into the risk models that are developed by CIFER to run the risk analysis. Because this process is automated, this automation will allow the user to be able to run risk as often as needed, which enables the real-time quality of risk. And once we've run the risk analysis, we're able to view the analysis results in the dashboard, and we're able to have a comparison with industry performance. So it's including industry, comparing it with industry incident data, which includes 20 years of PHMSA data, and a real-time risk analysis now with this information presented as compared to your peers can now be used for decision-making, budgeting, and developing action plans to deal with the risk. And once we've completed the risk analysis, we're able to take that information and roll that back into our core SIM module within integrity compliance. So we're closing the loop from risk and integrity compliance, and we're using risk to inform our integrity management programs and anomaly analysis. So we keep mentioning actionable POF. So what do we mean by actionable POF? So we're looking to identify where mitigative action may be needed to drive risk below the reliability threshold. The threshold line that you see here, the dashed line, is determined by analyzing incident data from industry as well as PHMSA's incident database from over 5 decades to establish quartiles of risk performance. Utilizing industry incident data gives us the framework to be able to allow you to compare how your risk data compares to your peers. So in this case, we're looking at when the user is assessing their data, they're assessing their data based on how their pipe performs versus the top quartile of industry reliability performance. This comparison allows the user to be able to assess their performance based on industry reliability standards, and it allows for additional insight into what threats are driving risks beyond this threshold. All right.
And I'll just provide more context to that top quartile phrase. So the top quartile, really, we mean the Q1 or first quartile, which is actually the lowest quartile. So that's where you want to be, is you want to have the lowest quartile failure rate compared to your industry peers. So a bit of a misnomer there, but top quartile just sounds better than lowest quartile. So that's why we call it that top quartile for failure rates. And I'll just go ahead and explain where we are with SIM. So Anup is showing the homepage, and at the top is where you'll see the main processes for SIM. So to explain to those of you who aren't familiar very briefly, the SIM processes, the main ones are assessment planning first. Assessment planning is where you plan and manage all of your inspections. This is also where you upload your inspections, your inline inspection data, or your external corrosion surveys. And this is where the machine learning classifier works to classify all the anomalies and the features correctly, make sure that your inline inspections are automatically aligned to previous inline inspections and also to all the pipeline data that's being synced through your GIS, if that's applicable. And then integrity compliance, I think we've mentioned previously, that is the process where you analyze your anomalies, determine if they meet certain conditions that you've identified, and then also identify anomalies for repair. And then dig management is where you organize the anomalies that you've identified for repair into digs and generate dig plans. And there's a lot of auto-generated dig plans and reports and sheets in that module. And then threat monitoring is where you capture the dig data, or you also can document repairs and recoats if you've mitigated. See, there's threat monitoring for CIS and CP. If you've identified like a test station that doesn't meet a certain threshold for CP, you can document the mitigation or what you've done to evaluate that. For inline inspection, you can document the actual anomaly depths, so you can generate 1163 analyses, etc. And so the risk management module is kind of embedded in one of these processes.
All right. So moving on to the risk management module here, we have here the landing page, which we do find under in risk management via processes. So this is the workflow that we've described before. Manage data. This is where we're able to assess the data sources that are applied to the risk analysis, and where needed, it'll give the user the opportunity to apply global defaults to the risk attributes that are necessary to run a risk analysis. Analyze data. This is where we're able to set up and execute a risk analysis. And finally, the dashboard, which is where we're able to view results and reports. So once we go through our risk analysis process, we're then able to feed this information back into integrity compliance, and that's where we're able to close the loop, so to speak, between risk management and integrity management. So let's start with manage data. So the number one challenge that we have in creating risk analysis, and this is something that's been discussed in industry, is the data collection efforts. SIMRISK has 66 attributes that it requires to complete the POF calculations, and finding, treating, and loading that data typically would take months and would require a substantial amount of effort. With SIM's ingestion and alignment algorithm, we're able to streamline that process. Data that informs the risk model is shown here with the origin identified. So the data source for each of the attributes here is identified. Each attribute has its data source identified. And for example, if we're looking for data that's been uploaded, we're able to see that these are the data sources that have been uploaded to this risk analysis. If we were looking for data that has been computed, we're able to see this here. For example, the depth of cover data is flagged as being computed. So where it's needed to be computed, so for example, the depth of cover calculations, we're able to see that here, and we're able to determine the source from this screen. Where data is not available, or if it's non-existent, this screen allows the user to the opportunity to input defaults. So you can upload defaults values via a uploaded spreadsheet template, or simply with manual entry to ensure that all the attributes for the CFIR models that the CFIR models require have data. So our intent with data management within SIMRISK is to drastically lower the upfront effort to create a risk analysis. Data management within the risk module is expedited and streamlined and can be customized to your organization's requirements. And data here is saved as part of the risk analysis and are updated and synced as risk data evolves and changes. One additional benefit to having data management contained within SIM and transmitted to risk via this methodology is that it allows audits and the user to be able to answer questions in these audits around data sources. They can easily be answered via the information provided within this screen. So once we've determined our data sources and have applied defaults where needed, we're able to create the risk analysis. And this is a screen where we'd be able to create a new risk analysis. And this is also where we'd be able to apply and set up the risk analysis and select which models that we wanted to include within our particular analysis. So here, we're able to select any of the 9 ASME B31.8S threat models that you wish to run. The flexibility in selecting these models allows the user to run risk analyses based on their needs. So for instance, if there is a certain threat that the user wishes to assess for a specific purpose, for example, an engineering assessment, they're able to select the required models to be able to make that happen. Whereas if it's a full risk analysis they wish to run, they're able to run that by selecting all of the risk models that are provided. We see here that we're able to select data from the core integrity compliance module. This feeds your ILI data into risk so that we're able to run risk analysis. So using the ILI data that's been ingested and aligned via the alignment algorithm, it means that the data is already treated and prepared for risk analysis. The issue concerning mismatched features or issues around alignment are already taken care of. So errors in the risk analysis are greatly diminished. Another advantage here is the opportunity for utilizing different integrity compliance analyses for each of the threats shown. So for instance, if there's an analysis for external corrosion that you wish to use that's different from the one for internal corrosion, that's something that the user can also select. The flexibility in being able to use multiple inspections for the risk analysis allows the user to customize their analysis for their needs.
And I'll just jump in here and provide more context to that. So that's really interesting feature because you can run different corrosion growth rate calculations on analyses. So like maybe external corrosion, you like to do pit to pit, but maybe internal corrosion, you have like a standard rate that you apply to all of your internal corrosion anomalies. So it's important that you can delineate which analysis, not just which assessment, but which analysis to derive the corrosion growth rate, which is one of obviously the attributes that drives the POF. And then, Anup, can you provide more explanation on what number of simulation years is?
So with simulation years, risk is calculated out into the future. Typically, with risk analyses, done, there are typically a single point estimate for the immediate year or perhaps the year after. SIM risk allows you to calculate risk going out into the future. In this case, the number of simulation years is 5 years that's selected. However, if the user wishes to increase the number of simulation years to fit their inspection interval, that can certainly be changed to accommodate that. So if it's a natural gas pipeline and the inspection interval is 7 years, that's a very easy change, and then that gives the user the opportunity to assess risk over the 7-year period between their inspection intervals.
Great, and that will come up again when we go to integrity compliance, because it will actually show you if your POF is going to exceed your threshold in the future. So like in 1 year or in 2 years. So that's wanted to point that out. And that's because this is also something that it took me a long time to realize, but POF is calculated in units of number of failures per mile per year. So there's a time component. So it's obviously important to input the number of simulation years to calculate that. So, all right, over to you.
Thank you. So once we've selected the models and the integrity compliance analyses that we wish to run, we're able to we're able to take a quick look at the attributes that have had the risk data aligned, and this gives the user the opportunity to do a quick check on the features or the attributes that are contained within the risk analysis, just to ensure that the data applied is correct. And it gives the opportunity for the user to make any changes and to see if there's any errors if the data does not meet the standard or meet the requirements of the user. So for example, we have depth of cover here. This is changed based on the mileposts along the pipeline, and the user, if they wish to change it, they're able to upload this information via their GIS within SIM and make those changes in there for now. So the source data tab here just makes data checks a little bit easier, and it's a quick way to see which attributes are applicable to the risk analysis, and if there's any omitted data or if there are errors in it, gives you as the user the ability to correct that. So once we've set up the model and we have selected the models that we wish to run, which integrity compliance to run, and we've seen that the data is applied correctly. Now we're able to go in and we're able to run the risk analysis. And once we've run the risk analysis, we're able to view the results within the dashboard. So the dashboard that's in SIM here is Power BI driven and is customizable to users' needs. The universality of Power BI means that it's easy to use and it allows for customization to meet the user's needs as they see fit. So this is the overall dashboard here. It gives the user the ability to view the POF calculated for each of the ASME B31.8S threats that are calculated, or in this case, they only show the value. They show the values of the threats that generate values. One thing that, as mentioned before with simulation years, is that it gives a view out into the future as to how the risk will evolve over time. So in this case, we can see with external corrosion, it increases as we go further out into the future. So once we're here, we're able to dive into our rolling mile risk analysis chart. One of the key points I wanted to highlight is having actionable risks. So we are able to compare it to the risk threshold, which is this purple dashed line here, and we're able to identify which threats are contributing greatly to the risk and exceed the risk threshold. So the ASME B31.8S threats here are also shown for each of the failure types: large leak, rupture, and small leak. If there are concerns that your organization would have for either failure mode, if ruptures are a concern, for instance, then that's something that the user could that the user could flag and identify where it ends up being an issue and which of the threats are contributing to that threat within that failure mode. So we're able to categorize by failure mode. It allows for better information, and you're able to inform your integrity management actions better. And once we have the comparison to the threshold, which is calculated as the top quartile of industry performance based on PHMSA incident data, we're able to flag where in the location the data is, or where the risk exceeds the threshold. So if we go back to large leak here, one thing that we do have is additional information based on anomaly data. So if we're looking at a corrosion feature and the user wishes to have some additional context, they're able to go through and view this information to gain additional context as to what the features look like, and perhaps some additional information on some of the surrounding features. So we have information such as feature dimensions, clock positions, calculated corrosion growth rate, just additional context for the user to go into that particular section and see what the anomalies in that area look like. All right, so once we've completed our risk assessment, we've assessed we've taken a look at the information, we've seen where the risk along the pipeline is the highest and what threat is driving the risk. We're able to feed that information into integrity compliance. So Sherry, I'll let you take over here from the perspective of the integrity engineer.
So an integrity engineer would come into integrity compliance. That's really where we analyze anomalies and run anomaly analysis. So you would select which inline inspection, for example, that you want to analyze, although the external corrosion module uses this too, and so you could analyze external corrosion surveys as well. And so when you're analyzing anomalies, it would calculate corrosion growth rates based on your settings, calculate burst pressures, time to failure, etc. That would show in this analysis results table. And then the highlighted anomalies are the ones that met the condition that you selected in your analysis. So when you start an analysis, you select which conditions you want to kind of grade the inline inspection by, and then that will show you which ones met that condition. So we kind of ran one specific to this risk analysis, and these are showing anomalies that exceeded the probability of failure, the probability of failure exceeded the reliability threshold. So this is kind of like full circle, showing how you can use inline inspection data to calculate corrosion growth rates, to calculate probability of failure, and then use that probability of failure to feed back into integrity compliance and identify which anomalies to mitigate or add. So if you click on the information, you can get more information about this particular feature. This feature history is really great because it's driven by the automatic alignment of inline inspection. So this is showing the depth history from 3 different inspections, which is really great. That's obviously what's driving the corrosion growth rate. And this alignment is done automatically in assessment planning when you upload these periodic inspections. And then the risk analysis tab, I'll let you, Anup, show or explain what that data is showing.
Sure. So the risk analysis tab here in this table here allows for additional context for the anomalies. So here we're able to see the risk score for each of the 9 threats that were analyzed, and to assess which of the threats are the greatest contributor for each of the failure modes. In this case, we see here that third-party damage is the greatest contributor. And another insight that we're able to get from this risk analysis information tab is how the POF is changing for each of the failure types and the time to exceed the reliability threshold. So that years to failure really means the years to exceed the reliability threshold. So here we can see that for small leaks, it has exceeded the PHMSA reliability threshold. However, for large leaks and ruptures, there is still a year left before it does exceed that. So it gives you additional context and information to be able to take action and to be able to action based on a POF. So be able to feed this information into your integrity management plans and be able to take action that way. So.
Yeah, I wanted to drive that point home about the years to failure is that that's a bit of a misnomer. It's really the years that the anomaly will exceed the reliability threshold. We do calculate another years to failure based on accursion growth rate, or in the situation with pressure cycle fatigue analysis, we calculate a crack growth rate based on cyclic fatigue severity. So that's a different value that would be shown in the table in the background. So a lot of information for you guys to select and use or select anomalies to repair. A really good application for this is for, I would assume most operators usually go above and beyond what's required by code. So obviously we have all of those conditions in our condition library of what's required by Code of Federal Regulations, liquid and gas, but a lot of our clients go above and beyond what's required by even their IMP. And so this is really useful information of looking at POF values and looking at, risk holistically. So that's all from me.
Thank you. So that's an overview of the risk management module and how it feeds into integrity compliance and how it really closes the loop between risk and your integrity management program. We're able to expedite the data loading via our machine learning algorithm, and we're able to take advantage of that, make sure that the data is aligned and adjusted properly, which would reduce errors in your risk analysis. And then from there, once we've completed the risk analysis, that information can now be fed back into integrity compliance, and you're able to use that risk information to really conduct risk in real time. So being able to, on a per ILI basis even, take that risk information and have it be actionable, have it be something that you can inform your DIG programs or your integrity management programs in general.
I just want to make sure does anyone have any additional questions? If you do and you want Anup to show it in the demo, he can. On that note, about user-defined thresholds, a question came in, like, if you don't want to use the PHMSA top quartile threshold, can you define your own threshold that you compare yourself to?
Absolutely, you're able to do that. So if we go back into our risk analysis setup screen here, we're able to define them for each of the threats, and we're able to define them based on product, at least at a high level. So for gas and liquid, and for each of the 9 threats that are defined, you're able to select and you're able to enter the threshold that you wish or that your organization's internal guidance provides. So that's certainly something that you're able to have and modify for your organization.
Okay, great.
All right. All right, so looking into the future here, or at least for the immediate future here, we're looking to roll out what we've defined as phase 2. So that's our actionable POF module. So being able to compare to industry or peer performance for each of your ASME B31.8S threats, and being able to utilize the data that's already within SIM to run your risk analysis, to expedite your risk analysis program, and to be able to really apply a real-time component to risk, incorporating it into your integrity management workflow, and be able to compare yourself to your peers. In phase 3 and beyond, we're looking to improve upon that. We're looking to refine and build upon the foundation of actionable POF. And Sherry, anything else to add? Yes. And for enrollment, sorry, go ahead.
Oh yeah, sorry. I was looking at someone had just entered a question. Maybe you can take a look at it while I'm looking, or while I'm talking. I can't do two things at the same time. So,
Sure.
I was gonna mention I would be a bad product marketing person if I didn't mention that we are now enrolling for our early adopter program, and if you sign up before July 31st, that we are actually waiving the subscription fees for the risk module. So we are all going to send, or I'm going to send all of you a follow-up email discussing that, and just reply to that email if you're interested or you would like more information. And if you're just so eager that you can't wait for that email, then you can email us directly at sales@earthsolutions.com.
If there are any questions, feel free to email me at the email shown on your screen. Happy to answer them.
All
All
right.
right.
Well, thanks, guys. Thanks for your time.